Okay, welcome back, everybody. We're going to jump into chapter 8 today after we finish chapter 3. We didn't quite finish last time, so there's just a little bit more of chapter 3 I want to look at. We're skipping over some stuff. We're not doing diagramming, and we're not focusing on the assessing long arguments section. There's just not enough time to do everything in a short course like this, so we're just skipping over that and we're going straight into logic, right? And you're going to learn how to do propositional logic. Um, but let's finish up chapter 3 here. Right, so this is a good place to just refresh your memory on a couple of different valid argument formats. Right? When we do logic, you learn how to prove that an argument is valid or invalid. So you don't have to rely on being able to spot, right, the formats, because there's only a handful of formats that we really identify and give a name because they're really common. But there's all sorts of different ways that you could format an argument that could be either valid or invalid. And so propositional logic is a tool to help us determine, is this argument valid or invalid? But you don't necessarily always want to sit down and do propositional logic, and very often the argument is in one of these forms that we recognize. So it's good to be acquainted with each of these formats. But these four are all valid argument formats. There's two other ones that we have a name for that are tempting to use, and sometimes people think they are valid. And I can tell from the exercises and the quizzes that you are misled into thinking that these are valid argument formats. And so it's good to learn about those as well. For now, remind yourself of these ones, right? Modus ponens, otherwise known as affirming the antecedents, right? And why would we call it that? Oh, hi, Nivan. Welcome. Thanks for being here. As always, stop me if you have a question. I was just explaining that modus ponens, we could also call it affirming the antecedents, because we sort of name it after what that second premise does, right? That first premise is a conditional. If A, then B. And remember, A, the first part, is called the antecedent, and B, the second part, is the consequent. So that second premise there is saying that the antecedent is true, right? The premise says, if A is true, then B is true. That second premise says A is true. That then allows us to infer that B is true, right? So that's a modus ponens, that's valid. Any simple statements that you throw into A or throw into B, whatever argument you end up with, if it's in this format, it's valid, right? Same for modus tollens, which is sometimes known as denying the consequence, right? Because that second premise is negating something, it's denying something. It's denying the second part of the conditional that says if A then B, it's saying not B, right? So denying the consequence. Then you also learned about the hypothetical syllogism and the disjunctive syllogism, right? And the disjunctive syllogism introduced the idea of or, right? So as always, I'm trying to get you ready for logic. Here we can see some of the main pieces that we use in the game of logic. We see the if-then type of statements. That's very important. We see A or B type of statement. That's very important as well. And then we see not, right? That little word not that denies something, that negates something. That's going to become important as well. Okay. Beyond that, we just have one more piece, and that's the and. Right. We'll look at that a little bit as well. But just to make you unintimidated about logic, the way that I'm going to present it is a easy version of propositional logic, and you can think of it as a little game, right? It has a game, it has a point to it, right? There's something you're trying to do. Is the argument valid or invalid? And to play the game, you really just need to know these four pieces. And these four pieces are things you already know from normal life, right? You already understand the concept of if then, right? You already understand the concept of A or B. You already understand the concept of A and B. And you already understand the concept of not, right? So we take those four things, then that's enough for us to do logic with, right? And so that's fine. You'll be able to figure it out. Just stay with me for each step. This is the exercise I wanted you to do. So this is the part that we did not get to, right? So in modus ponens and modus tollens, each time the first premise is a conditional, and then the second premise will affirm or deny, right? It'll affirm either the antecedent or the consequent, and then it will deny either the antecedent or the consequent. That gives us four possibilities, right? We only saw two, right, for these ones, modus ponens and modus tollens, right? We're affirming the antecedent, but we could have also affirmed the consequent, right? We didn't do that. We only affirmed the antecedent. And here we denied the consequence. Well, we could have also denied the antecedent, and we didn't do that. Right? Well, that's because we're focusing on valid argument forms. Those other two possibilities both represent invalid argument forms. So let's look at those just because they are common. People use these patterns as ways of reasoning when they're not reliable ways of reasoning. Right? So we could have affirmed the consequent, or we could have denied the antecedent. We didn't look at either of those. So let's look at these because they are things you want to avoid. Right? So this shape of an argument we haven't looked at yet. First, conditional, right? Just like modus ponens and modus tollens. But then that second one affirms, but in a modus ponens, it affirms the antecedent. In this one, it's affirming the consequent, and that is not a valid argument form. If you say if A, then B, and then you say B, you can't infer that A is true, right? This just says A leads to B, okay? But it doesn't say that A is the only thing that leads to B, right? So just because you see B, right, it doesn't mean that A has to be true, right? So if you give me $1 million right now, I'll have a smile on my face, right? I have a smile on my face, kind of, because I kind of enjoy this, right? Uh, well, did you give me $1 million for it? No, there's other reasons for it, right? So if A then B doesn't say only if A happens, then B happens. So you just can't infer that A is true just because B is true. So if we look at an example, this example might not be clear. People get confused about this. People think that this is valid, right? Whenever I'm hungry, I get a snack. I'm getting the snack right now, so I must be hungry. That follows that format of affirming the consequence, right? I'm saying I will get a snack right now. I'm affirming the consequence. And then I infer that I must be hungry. That's not valid. That's not right because, don't you often get a snack when you're not hungry? It could be true that you get a snack when you are hungry, but you might also get a snack when you're not hungry. So it doesn't follow from the fact that you're getting a snack that you must be hungry. You might get a snack just for the fun of it, right? Because it tastes good. So it's not valid. And this one, I think, will make it much more obvious. But it's kind of funny how you can use different examples where it's more or less intuitive, right? This one, I think it's very intuitive. I think everyone will realize what a stupid mistake it is to use affirming the consequent. It makes no sense, right? This argument format here goes along with that format as well. It's also affirming the consequent. If I'm a millionaire, then I have money. That is true, right? If I'm a millionaire, then it is true that I have money. I have money. That is also true, everybody. Not a whole lot. I could use with more, that's for sure. Because I am not a millionaire, right? So the fact that I have money, I can't infer from that I am a millionaire. It is true that if you're a millionaire, then you have money. And it is also true that I have some money, you have some money. Does it follow that you are a millionaire? No, unfortunately, it doesn't. I wish it did, but it just doesn't. It's not a logical inference. But that's the thing about argument formats. It doesn't matter what type of statements you plug into it, it stays invalid. Right? So just because this example it's not as clear that it's invalid doesn't mean that it isn't invalid. It's just as bad as this more obvious example. Okay. So it's not a good way of reasoning, right? It's a logical mistake. You're think you can draw an inference, but you actually cannot. Okay, so that's affirming the consequent, that's invalid. And then we also have the other possibility, right? Denying the antecedent. Denying the consequent is just fine, right? Modus tollens. Modus tollens is always valid. If you say if A, then B, not B, therefore not A, that is valid. That always works, no matter what you plug in. Here, when you deny the antecedent in that second premise, and then you infer, you conclude the negation of the consequent, you say not A, therefore not B, not valid. Right? That's denying the antecedent. Give you an example. If it's sunny, then I'll go to the beach. It's not sunny, so I won't go to the beach. Again, some people just feel intuitively that this makes sense. And there's probably some way of interpreting that's happening, right? Psychology is interesting. I think what happens is that people interpret it uh, in the most congenital way, like the most uh, in the most friendly way, right? That there's some interpretation where this makes sense. But explicitly as stated, right, the way that it's stated, it's not logical, right? If it's sunny, I'll go to the beach. If not sunny, so I won't go to the beach. Classic denying the antecedent. Because we can do the same test as for the previous one, right? Let's say that it's true that on sunny days you like to go to the beach. And let's say it's not sunny today. Let's say both of those are true. Is it still possible, logically, that you would go to the beach? Yes, yes. The truth of those premises does not prevent you from going to the beach, right? You could go to the beach even if both of the premises are true. So that means both of the premises could be true and the conclusion could be false, but that's not a valid argument, right? In a valid argument, the truth of the premises guarantees the truth of the conclusion. In a valid argument, if the premises are true, the conclusion must logically also be true. In this case, we don't get that. Both of those premises could be true, and yet the conclusion could be false. But once again, the choice of example matters, right? I can give you a clear example where right away you'll go, yeah, that's not logical. At least I hope so. If I'm walking, right? If I'm walking around, that means I'm alive. True, right? Unless you're thinking of some zombie scenario, but we're trying to be realistic here, right? If I'm walking around on Earth, then I'm alive. I'm not walking. That's true. I'm sitting down. Can I then conclude that I'm not alive? No, right? That makes no sense. It's true that walking around means you're alive. But walking around isn't the only thing that shows that you're alive, right? Talking shows that you're alive too, and I'm doing that. Right? So both of those premises could be true, but the conclusion doesn't logically follow. Right? And so here, that's clear to anybody looking. I think it's clear. But in other cases where you're not so sure, like the previous example, you got to just be able to spot that pattern and realize that that's not a reliable way of reasoning, right? The truth of the premises there does not tell us that the conclusion is true. So you should not trust these arguments, right? These type of arguments should not be the things that convince you. I should pause to make very, very clear. This is something that people get wrong all the time. And once again, by looking at the exercises and the quizzes, I can tell that people get this wrong. Let's say you do have a bad argument. Let's say you have an argument that affirms the consequent. What I'm saying here is you should reject that argument. Right? That argument should not be enough to convince you that the conclusion is true. That's it. It doesn't mean that automatically the conclusion of that argument is false. We don't know that. All we know is this particular argument does not support the conclusion. That's all you can conclude, right? So when you, as a critical thinker, reject an argument, you are rejecting the argument. You're not rejecting the conclusion. That doesn't make sense. You have to think independently and critically about whether you think that conclusion is true or false. Simply showing that the argument for it is bad does not mean that the conclusion is automatically false. It just means that argument is bad. Okay. I've said this before, but I have to say it over and over because people forget. So people do use these argument formats, right? People rely on these fallacious ways of thinking. Yeah, exactly. When you add only, right, that makes all the difference. And I think that's that charitable reading that I was talking about. I think people sometimes see the arguments and they actually, maybe you're intuitively doing something that you should do as a critical thinker, which is to steel man the argument, right? Give it the best interpretation possible. So I think people are supplying that, like, oh, they mean only, right? Only if A, then B. Then you could say, well, not A, therefore not B. Right? Yes, very good, Nevin. That you've cracked the code there. Yeah. Then it's different. It's completely different. Once you put only in there, it's different, right? Uh, in fact, when you put only in there, you're kind of switching the B and the A, and so that turns it into a modus tollens. Weirdly enough, right? Adding the only, this is kind of high app level stuff, but adding the only kind of turns it into a modus tollens. Very good. Yeah. So because you're adding knots, right? Knots is one of these pieces that I'm talking about, one of these logical pieces. Not changes everything. It changes everything around. Oh, sorry, and only as well. Sorry, no, I didn't mean not, but only, right? Only changes everything around. It sort of flips the antecedent and the consequent around. Okay? So then when you deny the antecedent, you actually end up denying the consequent, right? So let me test that out to make sure really quick. Uh, if you're saying only if I'm walking, then I'm alive, then you could drop only and just switch them around. You'd be saying the same thing. If I'm alive, then I'm walking. I am not walking, therefore I'm not alive, right? It's turned into a modus tollens, adding only. And if you want to translate it into if-then statements, all you need to do is switch the antecedent and the consequent. And it's the same truth. But then you can see that it suddenly looks like a modus tollens instead. Okay, good. I'm glad you're seeing those connections. That means you have a logical mind. Uh, People use these argument formats because they have that appearance of a logical flow, right? They have that appearance of a deductive argument. It kind of looks, right? If you squint, it looks like a modus ponens or a modus tollens, right? It's kind of like somebody dressing up in a police uniform, right? You're like, oh, that person should, well, police maybe is a bad example. I don't know. Some authority, right, looks a certain way. And you're like, oh, that person's trustworthy. And here's somebody dressed up kind of like them, right? And you trust them. Well, no, right? Uh, Even though affirming the consequent and denying the antecedent look a whole lot like modus protonals and modus ponens, you cannot trust these argument formats. And because they're invalid, then any argument that contains them or uses them becomes overall unsound. Because remember, soundness requires validity and true premises. And here we've seen validity is failing. Right? So the argument is not sound, and so it should not convince you to add that belief to your mind. So just make sure you know each of these, all 6 of these, right? You'll need this for the quiz. The modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism, affirming the consequent, and denying the antecedent. 4 of those are valid, right? The first 4, and the last 2 are invalid. Right? Let me reiterate this again just to make sure. There's all sorts of different formats that are possible. Some are way more complicated. All of these just involve 2 simple statements, right? An A and a B. Some arguments will have very complex statements with an A and a B and a C and a D and an E, right? All sorts of simple statements packed into it. And those argument formats could also be valid or invalid. They just don't all have names. Right? These ones have names because they're very simple and they're common, right? Simple, common argument formats. 4 of them you can recognize as being valid. Right? So when you're asking the logic question and an argument has that format, you go, okay, logic checks out. If they have either those last ones, affirming the consequent or denying the antecedent, then you know the answer to the logic question is no, it did not pass the logic question test. Not valid. Okay, let me switch out to my chapter 8 presentation. This takes a second to connect to my phone. By the way, there's no particular reason really that I put animals on these. I just like the balance, maybe. The thinking is so abstract and logical, right? Nice to see some life in there. And it just makes it all a little bit less scary, I think, when you see cute animals. So that's the only reason I really include them. Oh, still getting ready. Come on. It's done this before where it just doesn't do it. Okay, I'm going to have to start it again. There we go. Okay, we are on chapter 8, so everyone aware of this, hopefully. We skipped from chapter 3 right into 8. Oh, somebody else is here. Hi, Guadalupe. Nice to see you. Good. We're going right from 3 to chapter 8. It shouldn't say part 5a there. That's old. That doesn't make sense. I thought I changed that. Oh, well. It's fine. We went right from chapter 3 to chapter 8. It makes more sense, really, because a lot of the stuff that we're learning about in chapter 3 carries over directly to chapter 8 in a way that's not true of the in-between chapters, right? So those in-between chapters are good. We will get to them, but this has a much better flow, I think, anyway. So we are going to learn what's called propositional logic. Looks a little off. Oh. Yeah, great. You got disconnected again. Yeah, for some reason it's not centering very well. But hopefully once they oh, okay, there we go. That's better. That's all right now. Okay. Okay. So we're doing propositional logic. I'll explain what that is. This is sort of the flow. First, we're going to look at the idea of statements, which you already know a little bit about, complex statement and simple statements, and then the idea of these operators that we're going to use in logic. Those operators are just things that I already mentioned. If then, or, and not. Just 4 pieces. I like to think, if you learn how to play chess, right, there's 6 pieces that you have to learn how they work, right? Chess is more complicated than propositional logic is, at least at this level. Propositional logic can get very, very complicated, but we don't need to for a class like this. The whole point of this is for you to use that purely logical part of your brain. Right? People often ask about math, will I use this in real life? Well, if you ask that about propositional logic, my honest answer is probably not, right? But you are, in a class like this, you're going to be forced to really flex that muscle, right? To really think in a purely logical way. And that's something we don't do very often at all. And so a class like this is an opportunity for you to do that. And I think that once you go through that process and you get it, it all clicks together. I do think it'll make you a better critical thinker, right? I really do believe in it. Even though I don't think you're going to be translating everyday arguments into the language of propositional logic, right? Okay, well, let's just jump in. I was going to go through each one of these to tell you, but no, we'll just jump in and you'll learn what each of these things means. Let's go right into statements and operators. First, I'll kind of explain a little bit more what propositional logic is about and what it does. Right? It gives you a method. It gives you a method to figure out whether or not a particular argument is valid or invalid. And so earlier, you're just kind of being told to trust, right, that a modus ponens is valid. But with propositional logic, you can prove it for yourself. You can prove for yourself that modus ponens is valid and affirming the antecedent is not valid. Doing logic gives you a multi-step technique that allows you to determine for once and for all, right, is this valid or invalid? Like I said, there's many different argument formats. They're not always going to be one of those six main ones, right? They're not always going to be that. They're going to be something else. So if you really wanted to prove, right, using the tools of logic, then you could do that using propositional logic. And I've mentioned this before as well, but I'd just like to say it again. Remember how ubiquitous and important logic is. Right? In certain ways, logic is the underpinning of science itself. And logic also runs all the software that our lives depend on, right? All these computer apps that we use, all this stuff is all dependent on basically, right? Computers run on logic. And if you ask some philosophers, they'll even say that the universe itself, right, obeys the laws of logic. That logic actually shows us the most basic metaphysical truths about the nature of reality. Now, that's a controversial thesis, right? You don't have to agree with that, but it's an interesting thought anyway. Right? I'm trying to be honest about this, right? That you probably are not going to. Sometimes I feel like that's the expectation in a critical thinking class. Like, well, you're going to learn how to be a critical thinker. So here's what you do: you take ordinary language and you translate it into a bunch of symbols, and then you do these truth tables, and then you determine validity. And then you can figure out if the argument was valid, and then you still have to figure out if the premises are true, et cetera, et cetera. That like you would actually do all this. People are not going to do this. Philosophers don't do this. Logicians don't do this. Right? Logic is its own kind of game that you can use logic, like I said, to write code if that's what you're going to do, right? Or you can use logical thinking to do science, right? But in terms of actually using propositional logic itself for the everyday person to be a critical thinker, I don't think they're going to do it. But I think there's a great rationale for it anyway, right? A reason for studying propositional logic in a class like this, because it will sharpen that part of your brain that is able to do this kind of thing, these reasoning skills and this logical thinking. For some people that comes very naturally anyway, right? Some people need a little bit of help thinking that way because it's not necessarily natural. People use all sorts of mental shortcuts to make decisions and to do reasoning. Right? So this forces you to slow down and only look at what's relevant for pure reasoning. Right? So there's an analogy, right? You go to the gym and you lift weights. Is that because you're training to find some weights out in real life, right? You're doing chores and suddenly someone says, well, you cannot get your groceries until you lift some weights, right? No, right? That's not why you do it, right? You do it to strengthen your muscles and to stay physically fit, right? You do these concentrated exercises, about lifting weights. That's something kind of unnatural that you're not going to be doing, and yet it is good for you. It's good for your body. It's good for your physical strength and endurance and your health, right? So in the same way, you could do logic, right, to strengthen that logical part of your brain and to stay mentally fit, right, and to understand how logical inferences really work. So I've already compared it to a game, right? Now you can compare it to a kind of mind strengthening game. So there's in the game itself, what is it you're trying to do? You're trying to figure out, is this argument, this deductive argument, is it valid or invalid, right? That's the game itself. Uh, the point of playing it is to become a better critical thinker, right? It's working out is what you're doing. Right? Only it's the brain doing it. Now, this is kind of literally kind of true. It just makes it sound more exciting than it probably is, right? But this is what we're doing here, is we're traveling through logical space. That's a way, at least, to characterize what it is we're doing when we're figuring out if an argument is valid or not. Because remember the definition of validity. In a valid argument, it is not logically possible for the premises to be true and the conclusion to be true. So philosophers sometimes talk about possibilities with the word or phrase possible worlds, right? So it was possible that maybe I'd worn a different jacket, right, today when I came to this meeting. I could have worn a different jacket or maybe not wore one at all. That's a possibility. So instead of calling it a possibility, we could also just say there's a possible world where I wore a different jacket. We don't necessarily mean that that world really exists, right? Some philosophers think possibilities are real in a concrete way. We don't have to go that far. We can just say there's a possible world where I wore a different jacket, right? There's a possible world where you drank something different today than what you actually did, right? There's all sorts of possibilities. Things could have been a different way. Things could be this way, they could be that way. We can represent possibilities as possible worlds. So when we say in a valid argument, it's not possible for them to be true premises and a false conclusion, we could also just say there's no possible world at all where this argument's premises are true and the conclusion is false. Because that way, we don't have to determine if the premises are really true. We can just look at all the different possibilities that there are. Right? And if there's no possible world at all where the premises are true and the conclusion is false, then we can say the argument is valid. Right? Is there a logically possible world where the premises are true and the conclusion is false? That's all we're asking. Right? When we're asking, is the argument valid? Right? Is there a logically possible world where the premises are true and the conclusion is false? Right? That's the definition of validity, right? In a valid argument, there's different ways to phrase it. I hope you can see these are all saying the same thing. In a valid argument, the truth of the premises logically guarantees the truth of the conclusion, right? Definition number one. That means that in a valid argument, it's logically impossible for the premises to be true and the conclusion to be false. Now we can go all the way and translate it into possible worlds talk, right? There is no possible world in which a valid argument has true premises and a false conclusion. You don't have to yet envision what this is going to look like when you do logic. Okay? I'm just telling you, describing it from a distance. Right? This is what we're going to end up doing in logic, is we're going to look for possible worlds. possible worlds in which there are true premises and a false conclusion. And the logic allows us to do that. It allows us to travel through logical space by representing things in a logical way. We can look at all the possibilities, and then we can just figure out, right, is there any possible world where there are true premises and a false conclusion? Okay, so that's part of the game, is traveling through the corners of logical space. Okay. And again, you don't have to fully understand what that's going to look like yet. You'll find out what that looks like. Right? I also, in order to make it more exciting, right? Look, what we're doing is we're trying to find that pattern, right, of an argument that has all true premises and a false conclusion. Right? That's what we're looking for. And if we don't find it, then the argument is valid. Right? So we're looking for a pattern. We're looking in all the possible worlds. Is there a situation where the premises are all true, every single one of the premises is true, and the conclusion is false? And that's what we're looking for. And I call that pattern a gremlin, right? Remember old-fashioned gremlins, right? In like World War I or II or something like that. Something wrong with the airplane when they're flying it. It's a gremlin doing it, right? Gremlin means problem, right? Gremlin is not good. So an argument, right? We can take an argument through logical space, and we could find a gremlin. Right? A gremlin is true premises, false conclusion. Right? If we find a gremlin, the argument is not valid. If we don't find a gremlin, the argument is valid. But to do this, it's easier if we translate it all into symbols, right? In propositional logic, we'll end up using symbols. We'll have symbols for each of those four things I talked about, right? Or, if, then, and, not. Right? There's symbols for those. And then simple statements. We just assign a variable. We just go P or Q, right? Socrates is mortal can turn into the letter M, right? The letter M can just be a true or false statement. Socrates is human. We could represent that with the letter H, right? So H is a true or false statement. And that way we can just turn all this language into something more compact. And that allows us to just look at the logical form, right? Because to determine validity, all you need to know is the logical form. You don't even need to know what the individual statements say, right? All you need to worry about is the overall structure, the format of the argument. Hopefully you saw that earlier, right? So if I say, if A, then B, A, therefore B, you know that that's valid, even though you don't know what A or B even stand for. We haven't assigned anything to those variables. And yet you know that that argument format is valid. So that means we can just take the words out altogether and just have symbols, right? So that the letters are true or false statements, and the symbols are those operators that I talked about. And that's going to be all of propositional logic. That's all it's going to be, right? You're going to have letters from the alphabet that represent individual statements like Socrates is mortal, Socrates is wise, right? Whatever it may be. Socrates wears togas. And then you'll have four different symbols for those ideas of and, or, if, then, and not. Right, so just to give you a preview, this is what it might look like, right? If Socrates is human, then Socrates is mortal, right? That first statement is, we're going to turn Socrates is human into H. And Socrates is mortal, we'll turn that into M. And the if-then statement, we can represent that with a little arrow, right? We already said an if-then statement is basically saying A leads to B. So we just have a literal arrow that says H leads to M, right? If Socrates is human, then Socrates is mortal, right? The arrow tells us that it's an if-then type of a thing. And then the second premise says Socrates is human. Well, we already decided Socrates is human, that we'll use an H to represent that simple statement, right? So we have our first premises. H, arrow M, right? H goes to M, if H, then M. Second premise, H, Socrates is human. Then we have those three dots that mean therefore. Right? Those three dots are just a conclusion indicator. Right? It just means whatever comes after, that's the conclusion. So the three dots, they're not very important. They just mean therefore, right? They just mean everything on this side is a premise, everything on this side is a conclusion. That's all those three dots mean. So don't let the three dots scare you. It just means therefore, so, thus, hence. It follows that. Right? And then we have the statement M, which means Socrates is mortal. Right? So that whole statement, if Socrates is human, then Socrates is mortal. Socrates is human, so Socrates is mortal. Right? That whole argument, rather, we can turn that into one little streamlined thing consisting just of variables and symbols. But there will only be 4 of those symbols, right? So don't let yourself get intimidated. And some of you are not intimidated at all. I just know, again, from years of experience, that for some people, logic is a little bit intimidating, especially people who already don't like math. Now it's like you're being asked to do math without the numbers, right? That's even more confusing. So this is just for some people. I'm just saying, it's at the end of the day, it's not that crazy. It's not that complicated. It just kind of depends on how you learn it and also how in depth you get. That's the other thing I've learned. For a class like this, it's not necessary for me to do really complicated propositional logic. I used to do that, but I really have learned that that's not really necessary. So we can keep it relatively simple. I made a mistake down there. That should say M and H, or H and M. But it doesn't really matter what 2 variables we use, right? But notice that the Socrates argument there has 2 simple statements, right? H and M. I accidentally said S and H, right? So forget that mistake. I meant H and M. Right? There's 2 simple statements. And when there's 2 simple statements, there are 4 logical worlds, right? Logical possibilities. Right? Right? If you don't know if H and M are true or not, you can know that there are exactly 4 possibilities, right? H and M could both be true. Maybe H is true and M is false. Maybe H is false and M is true. Or maybe they're both false. 4 logical possibilities. Just like with 2 coins, right? There's 4 different ways that they can land. Both heads, both tails, 1 heads, 1 tails, or 1 tails, 1 heads, right? 4 logical possibilities for any 2 statements. So if you have an argument with 2 simple statements, then we can just sort of see, well, what does that argument look like in world 1, possibility number 1, where both H and M are true? What does it look like in world 2, where H is true but M is false? What does the whole thing look like? And in any of these logical possibilities, do we end up with true premises and a false conclusion? Right? Do we end up with a gremlin? And that's it. That's the whole way that propositional logic works, at least this part of it, the stuff that you're going to learn. Like I said, it can get way more complex, but we don't need to go all that far. So the 2 statements could both be true, right? You'll get used to this. These are the different worlds, right? World 1, they're both true. World 2, the first statement is true, the second one is false. World 3, the first statement is false, the second one is true. And in world 4, both are false. So there's 4 different possible worlds. Let's take that argument and see if the premises are true and the conclusion is false in any of these worlds, right? Spot the gremlin in the 4 possible corners of logical space, right? And to begin with, we're only going to do arguments with 2 simple statements. So you always know there's just 4 corners of logical space to look at, right? Where they're both true, where they're both false, and then they take turns being the true or false in the other 2. No, none of this really makes you know how to do logic yet. That's totally fine. Just wanted to sort of explain the logic of logic, the philosophy of it, right? What this ends up looking like. And then maybe later on, you can go back to this and connect the dots fully, right? Once you actually do it, then this will maybe make a whole lot more sense. Okay. For today, I think we're going to be done pretty soon. Let's see. No, we'll keep going. So again, also to get you ready further for logic, let's recall this idea of a compound or a complex statement. Another typo. This always happens. I swear I go through and I check. And then whenever I present, I see the mistakes. Right? It says complex. I should say complex. The truth of a compound or a complex statement depends on the truth of the simple statements. Remember what a complex statement is, or a compound statement. Hopefully everyone remembers. This is an example, right? Work is done and I am ready to party. It's one sentence, but it's a complex statement because there are two simple statements inside of it that we could take them out and state them individually, right? Work is done. I am ready to party. These are two separate statements that stand on their own. But if I join them with and, then I'm saying something specific. I'm saying both of these are true. And then if one of them isn't true, then my complex statement is false. Right? Both of those simple statements have to be true in order for the complex statement to be true. That's for and statements. It's not going to be like that for other compound statements, right? But and works that way. And so when we end up with the and operator in logic, we just know, well, that's how the and operator works. And when you have a complex statement with two simple statements joined by and, well, the rule for that and operator, the rule is that the whole statement is only going to be true if both statements are true. So you can again think about logical space, right? There's four different corners. For an and statement, the and statement is only going to be true in that first world where both of the statements are true. Right, so any and statement that joins together two simple statements, that's the rule for and, right? That's the rule for and. That's how and works. Both of the things you said have to be true in order for the whole thing to be true. I say it's sunny and warm, right? That's a big one in Humboldt, right? Uh, to actually get both, right? Well, this is a complex statement, even though it's pretty short, and it's really, I didn't even separate it. I didn't even have two separate sentences joined by and, but it really is. It's two different statements, right? It's sunny on the one hand, and it's warm on the other, right? The complex statement asserts both at the same time. A little bit more complicated of a statement. Human beings have free will, and everyone is morally responsible for their behavior. This also breaks down into two separate statements, right? Human beings have free will. Everyone is morally responsible for their own behavior. Both of those statements, each individually, have to be true for that whole compound statement in the middle to be true. If either one of them is false, then that whole thing in the middle is false. Even if it ends up saying one true thing, right? Let's say that everyone is morally responsible for their own behavior, but humans don't have free will. Well, that big statement said one true thing, but the whole big statement itself, we can say, is false, right? Because it's saying that both are true. That's incorrect, right? It's saying something incorrect if it's saying both are true when only one is true. Katie ate the last cookie and she's not sorry at all. Katie ate the last cookie. Katie's not sorry at all. Right? Both of those statements have to be true in order for the whole statement to be true. Okay, that's probably pretty clear to people. Right? The important thing to remember is that the rules are different for other types of complex statements, compound statements, right? Like an if-then statement. Right? If P, then Q. There, the rules are different. Or an or statement. Right? For an or statement, it's going to be different as well. For an or statement, you don't have to have both of them be true, right? For an or statement, you need at least one of them to be true, but you don't need both to be true. Right? For an and statement, both have to be true. Yeah, this is what I'm saying, right? Sunny and warm, that's really nice. Actually, it's been kind of like that lately, a little bit here and there. It's both sunny and warm. Very often, right? So if I tell you, hey, excitedly, hey, it's sunny and warm out, right? Then if you go out and you see that it's sunny, but it's all windy and cold, which happens a lot, right? Then I said something false, right? The whole thing is that it's nice when you get both. And if I tell you we have both and it's not true, then it's disappointing. What I said was false, even though I managed to say one true thing. The whole statement itself is not true. It happens the other way as well, right? Sometimes it'll be warm but not sunny, which I actually don't really like either because you often have this bad glare, right? When it's really overcast, sometimes the weather is more squinty than just sunshine. I don't know what's up with that. I don't know if everyone feels that way, but anyway, really just hitting you over the head with this idea, right? That you could have a compound statement whose truth depends on the truth of the small statements, right? So if you got that, good. So like I said, it's different from conditionals, right? We learned about conditionals already, right? With the antecedent and the consequent. Each of those also has its own truth value that then determines the truth value of the conditional. Remember this example? If you give me 100K, then I will eat a worm, right? It turns out for this statement is very easy for it to be true. There's only one logical possibility where that's false, right? So again, we have the two statements. You give me 100K, I will eat the worm. And there are four different quadrants of logical space, right? It could be you give me the 100K and I eat the worm. It could be you give me the 100K and I don't eat the worm. It could be you don't give me 100K and I'm still eating a worm, right? Or you're not giving me 100K and I won't eat a worm. Right? That fourth one is the world we live in, right? I'm not eating a worm. You're not giving me 100K, right? That's the actual real world, right? The only thing that will make that statement false is in that second world where, right, the first statement is true and the second one is false, where you give me 100K and I don't eat the worm, right? In that world, this statement is false. So that gives us the rule for how if-then statements work. Right? In both cases, it depends on the truth value of the simple statements. It also depends on if it's an if-then statement or an and statement or an or statement. And then we'll also learn nots, but not is a little bit different, as we'll learn, right? Those other three always connect two statements. The fourth operator that we're going to look at, not, just works slightly differently. It's still kind of the same basic idea. It just doesn't join together two statements. But eventually we'll look at each of these again more systematically. You'll really see how it works. I'm just telling you ahead of time kind of how it's going to work. So again, get these into your head. Try to get these four worlds into your head. Anytime we have two simple statements, and a lot of the arguments that we're going to look at with propositional logic, there's just going to be two simple statements, right? We saw that, right, with the modus tollens has two simple statements. Modus ponens has two simple statements. The disjunctive syllogism has two simple statements. Hypothetical syllogism has a third statement. When you have three statements, there's 8 possible worlds. And at that point, we need a quicker way to do it. We'll learn the short method. Once you have 8 different possible worlds to look at, we need some sort of technique to not have to look at all the worlds. But when you just have 2, then you sort of get just familiar with each of these 4 worlds, right? World 1, where both of the statements are true. World 2, where statement 1 is true, but statement 2 is false. World 3, the first statement is false and the second statement is true. And then world 4, the false world, right, where both statements are false. So world 1 is always the true world where both statements are true. World 4 is always the false world, right, where neither statement is true. Both statements are false. World 1, A is true, B is false. Right? World 3, A is false, B is true. Okay? So just kind of get those worlds into your mind. Number just learning through repetition, right? Hitting you over the head with the same idea until it breaks through. For some people, it breaks through right away. Other people need a little bit longer, right? There's 4 possibilities, right? For the statement, it's sunny and warm. It could be both sunny and warm. It could be sunny, but not warm. It could be not sunny, but it is warm. Or maybe it's neither sunny nor warm. Right? These are just all the possibilities. If you don't look out the window or check, right, you just know it's going to be one of those. But then we can also take that statement and take it for a tour through logical space, right? Let's travel to each of the quadrants and see whether it's true or false in that world. Right? So if we take it's sunny and warm to world number 1, there's a match. Yes, it is true in that world. Yeah. We take it to 2, it's not true in that world, right? This is denying one of the conjuncts, one of the things that we're saying is true. Number 3, it's not true in that world either. Number 4, it's not true in that world either. That tells us something about how and works, right? How it affects the truth value of the and statement, depending on what possible world we're in, what the possibility is. Okay? So if number 1 is the real world, then what I said is true. If world 2 was the real world, or world 3 or world 4, if that was the reality we're really in, then my statement that it's sunny and warm would be false. We can do the same thing for if-then statements, but then it changes, right? An if-then statement ends up being true in all the worlds except for 2. If you give me 100K, then I will eat a worm. Right? Well, if we're in world 2 where you give me 100K and I don't eat the worm, then my statement is false. But it's true in all the other worlds. So it works differently than an and statement. And an or statement also works differently. So this is what a truth table looks like. If you really want to look at all these possibilities, right? You could take the statement, it's sunny and warm, and you can break it up into the 2 components. You can look in world 1, right? In world 1, it's sunny and it's warm. Well, then if we look at the whole statement, we can say true right underneath of it, right? Because when it is sunny and it is warm, then it's sunny and warm is going to be true. In possible world 2, where it's sunny and it's not warm, well, then the whole big statement is going to be false. In world 3, the same thing, right? Because the rule for and statements is very rigid, right? An and statement only gets to be true in one of the possible worlds where they're both true. If we see a false at all on this side where it says it's sunny and it's warm, if there's a false on either side at all, then the whole statement is going to be false. So I hope you can see what this represents here, right? Each of the different possible worlds. Possible world 1, where it is sunny and it is warm, then my statement, it's sunny and warm, is true. So I put a T underneath of it. T for true, right? In all the other possible worlds, when either it's sunny or it's warm is false, or they're both false, then the whole big statement gets an F. That's why you see that pattern, T, F, 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 right? It's only true in the first world. Really quick, I didn't say this in here, but do you see the pattern that we have for any two statements, right? It doesn't have to be it's sunny, it's warm. It could be you give me 100K, I eat a worm, right? It could be Socrates is human, Socrates is mortal. Right? We could put anything there. But if we want to look at all the possible worlds, this is a nice way to write it down. Under the first statement, the pattern is TTFF. And then underneath the second statement, the pattern is TFTF. And that gives us consistently world 1 is where they're both true, world 4 is where they're both false, and then world 2 and 3 is where they sort of take turns being true or false. Right? So we're always going to set it up in that way, right? We always want to set it up in this way. When we have two statements and 4 possible worlds, we always want this pattern, right? Underneath the first statement, we go TTFF. Underneath the second statement, we go TFTF. And that guarantees that it'll line up in the same way each time. You just ask, well, where in all these possible worlds is that statement true? It's in world 1, right? Okay. So that tells us how AND works. So this shows us compound statements. The truth value of a compound statement depends on the truth value of the simple statements. That's always going to be the case. But then also on, are we using and? Are we using if then? Are we using or? And then later on, what about not? How does that work? We'll learn that too. There are more complex versions of propositional logic where you might get some other operators, but we don't need to do that in order to do basic propositional logic. That's the basic pieces, right? You have 4 basic things: and, or, if, then, and not. And then you'll learn how to actually physically play the game. I kind of told you the general idea of it, but it's always like that with games, right? Someone explains to you what the point is of Monopoly. You kind of get it, but you got to actually play it to really get it, right? So this is the same thing here. All that stuff I just said about what we're going to be doing, it won't really all come together until you actually do it. But this is the basic idea, that we have these 4 logical operators that you can identify how they work by creating a truth table. And then we can use that knowledge to test arguments, right? We can write out an argument and then take that to all the possible worlds. And instead of asking, is the statement true, we can say, is the argument valid, right? Because we can see in each world what the argument looks like. And if there's a possible world where the premises are both true and the conclusion is false, then we've spotted a gremlin. Then the argument is invalid. If in every world we look at, we never see the pattern TTF, right? Then we're going to be fine. Then the argument will be valid. All right, so the and is called the conjunction operator. And you'd already learned about the other ones just by looking at the other arguments, right? The if, then, the or, and the not. In modus ponens, right, we see the if, then. The disjunctive syllogism, we saw or, and we saw not. So that gives us all 4 of them, right? The if, then is called the conditional operator, because we already know if, then statements are called conditionals, right? Remember, conditionals have an antecedent and a consequent. Conjunctions have conjuncts, okay? So A and B. A is a conjunct. B is a conjunct. The whole statement is a conjunction, and the operator is the conjunction operator. The or is the disjunction operator. The whole statement, A or B, is a disjunction. A and B are called disjuncts, right? So A is a disjunct, B is a disjunct. And then we have the not operator, the negation operator. They each get their own symbol, right? So this is where now we're starting to really be acquainted with the pieces, right? This is why I'm showing you the chess pieces, what they look like, right? And we know what they do. We know what the and does, right? We know that the and joins together two statements, and then the and statement is only going to be true in world one, right? So you know how and works, but now it gets a symbol. Ampersand, right? That works. Sometimes logicians use different symbols, right? Sometimes they use a dot for an and, but the textbook uses the ampersand. That's just fine because people know that already, right? You know that that means and, so that should not be difficult for you to remember, right? So it's very easy then to translate everyday English into logic speak, right? It's sunny and hot. Well, we just assign a variable to it's sunny, let's say S, and we assign a variable to it's hot, let's say H. Then we can put an and sign in between of them, S and H, right? So S and H represented that way just means it's sunny and hot. But when we put it this way, we can stop worrying about whether it's really sunny or hot. We can just look at all the different possibilities, right? Because again, we could take that S and that H and take it to all these four different possibilities. We don't have to know which one's real. We just have to go to each of the possibilities. The disjunction, the or, gets this little V, which kind of is appropriate too because it sort of points to two different options, right? This or this, right? This thing over here or this thing over here. Right? The V kind of points like that, right? It's this is true or this is true. So it's either hot or windy turns into H, wedge, W, right? The variables that I picked, I matched them to the words, so I use H for it's hot and W for it's windy. You don't even need to do that, right? The variables are completely arbitrary. We could have said A or B. We could have said P or Q. That doesn't matter. The conditional, like if it's sunny, then it's clear skies. Right? Let's say it's sunny, gets an S. It's clear skies, gets a C. And then we just use that little arrow, right? It's an arrow. This leads to this. Right? If it's sunny, then it's clear skies. And then the negation is different because it doesn't join multiple statements together into one giant statement, right? It does make them, it makes simple statements complex because it's adding something or it's modifying the simple statement, but it's not adding another simple statement to it, right? So the negation just modifies a single statement. So for example, and the negation sign is the tilde, the little wave, right? So just remember that. The little wave means nope, not, right? So it's not windy. If we wanted to write that in logic speak, right, then we could just say, okay, let's say it's windy is a W. That's the simple statement. And if we want to say it's not windy, that's a complex statement. Not a compound statement, but it is a complex statement because the simple statement is it's windy. Right? And then we're tinkering with it, we're modifying it, we're denying it, right? So then we just write the tilde with the statement that we're denying, right? So it's not windy becomes tilde W or tilde P, whichever one you end up picking. Again, that's up to you. It doesn't matter which letter of the alphabet you pick to assign to a statement. Oh, my phone died. I think I'm pretty sure the next one is the last one that I was going to look at. It'll actually let me. Yeah, we'll stop at this point right here. Okay. This just it's just directly from the book, so you could see a nice streamlined version of this.